All right, so I'm going to continue on today. I'm going to move forward to the division of complex numbers. I think this is going to be my third day talking about complex numbers. And this is pretty much all that I'm going to go into, just the basics. This is stuff that we kind of brush across in high school. And then by the time you get to college, depending on what major you go into, you might get into it a little deeper with complex analysis. But I just want to kind of give you what the little foundational part is, and then I'm going to stop it there. So today, I'm going to just do the division part of complex numbers. All right, so here we go. These are mostly how you're going to be presented with a division part of, complex numbers, mostly like in this format. So this one says 5 minus 2i divided by 3 plus I. All right, so what you want to focus on is really the denominator. The denominator portion of the problem is where you want to focus on when we start doing the division part of it, because the standard that we said is we don't really like having complex numbers or complex terms in the denominator. And it has a lot to do with the same reason why we don't like square roots in the denominator. I teach AP Calculus, and I really don't care if a square root shows up in the denominator. But for standardized purposes and simplification purposes, it has been agreed upon that that's just something that we don't like to do. So it's the same thing that applies with complex numbers. We do not like keeping complex numbers in the denominator. So this right here is something that we have to focus on. So I go ahead and I start using my parentheses. And then from here, we're going to use something that I talked about yesterday, which is what we call a complex conjugate. And what happens is now that I focus on this denominator, remember a conjugate is going to do nothing but change that sign in the middle. So if this says 3 plus I, then over here I'm going to use 3 minus I. And that's what I do to the top and bottom to keep everything in proportion with each other. So this is where your organization kind of helps out. I know all of the stuff is written out over there, but I'm not going to do all the work over there because I want this to stay as neat as possible. I use a scratch sheet of paper. I use another area of my paper to do the work. Normally, I break it into top and bottom, and then I work these both out separately. Then I bring them back over there when I'm done. So my goal, or the best thing in my opinion, is to get the low-hanging fruit. And when I say low-hanging fruit, that is the stuff that's easiest to pick or the easiest to get correct. So 3 times 3 is 9. That's out the way. 3 times negative I is negative 3i. And then I'm going to talk about a shortcut after this example. If I multiply those two, I'm going to get a positive 3i. Then if I multiply these two, I get a negative I to the second. And remember, until we get used to it, we're going to slide that 1 in there where you can see it. All right. Now, negative 3i, positive 3i, those are gone. So now I have a 9. I squared means change the sign. So the answer here is 10. So when I take care of the bottom portion of the problem, my denominator is 10. And I can go through the same process again. This time I'm working with the 2 across the top. Start with my 5. I multiply times that 3. That gives me a 15. I do that 5 times the negative I. That's a negative 5i. That's a negative 2 times a 3, which is a negative 6i. And then that's a negative 2 times a negative I, which is a positive 2i to the second power. So your multiplication skills are crucial at this moment. If you are, if you make a lot of errors in multiplication and doing those type of calculations, this is going to be a problem. So you definitely want to make sure you're working on your multiplication facts, integers, knowing when you multiply, when things are positive, when things are negative. All of that is important. You don't memorize that to pass a test. You learn how to do it so that you know it. There's a difference. So that's something that you got to always stay on top of. So I've multiplied everything out and I laid it out where I can see it. And then basically I just go right through my skills. These right here, that's an algebra skill. They both have an I on the end of them. They both are negative. The total is negative 11i. Now remember, I have a 15 on the front. And remember, I squared means change the sign. And remember, that's a positive 2i. So what I'm looking at is a 15 on the front and a minus 2 on the back. 15 on the front. Change sign makes that a -2. And 15 minus 2 is 13 minus 11i. There we go. 13 minus 11i. And that's what goes to the top. 13 minus 11i. And that's it. So what I have here on the board is basically the problem that I just worked out. And remember, because by definition, I is equal to the square root of a -1, I put square root -1 there instead of the letter I. So I'm going to see what this calculator does when I tell it to calculate. Let's see. And notice how this says this is a non-real number. It gives us an error. So there's a way around it depending on what type of calculator you're using. But if you don't have one of these types of calculators, there's no way that you can use this to verify your own work. All right, so it's as simple as changing the mode. Now I got my mode changed where it should be able to work with complex numbers, and it won't give me that error like it did before. So I have it typed in now. I have 5 minus 2i divided by 3 plus I. And look what I have here. I have 13 over 10 minus 11 over 10i, which, if I'm not mistaken, looks just like that, right? Or this if I separate them out into 2 separate fractions. See what I'm saying? So that's how your calculators or your technology is able to get these answers, and that's where they're coming from. They're coming from that process that I just showed you. So kind of like what I did yesterday, I talked about the multiplication of complex numbers. When you're doing division of complex numbers, just like the example I showed you today, all you're really doing is multiplying the numerator and the denominator by a complex conjugate. So technically, the division part is multiplication. So if you can master your multiplication of complex numbers, the division is like nothing. All you're doing is multiplying the top part, writing its result. You multiply the bottom part, and you write that result. That's all there is to it. That's all I really want to do today. If you practice on some more of the multiplication of polynomials, multiplication of complex numbers, basically that should give you a strong foundation to get you moving in division of complex numbers. Find me on YouTube, BJ Jeffries. There's the correct spelling. There is a space right there in between BJ and Jeffries. You'll find me right there. I'm standing on a camel, pyramids in the background. That's my channel you subscribe to, like, and share.